Hi there, we're still on section 5.3. This is question 41 and 48 on page 239. Yep, still with conditional probabilities. So the book says let A and D, as in delta, be independent events such that probability of A equals 0.5 or 50% and probability of D equals 0.1. Find probability of A and D. Your book writes it like this, probability of A and D. So, in this case, because they are independent events, this is our giveaway that we can use the multiplication rule. So if the events are independent, we know that probability of A and D is the probability of A times the probability of D. So again, because they're independent events, we know that and we can use the multiplication rule. So in this case, this equals 0.50 times 0.10, which is equal to, my pen's being weird, 0.05. Sorry, my handwriting's so wonky. 0.05, that's the answer. And because you're multiplying the events, and we can multiply the probabilities because they're independent events, and we're looking for and. Suppose this has been a harder question. Here's a bonus. Suppose you wanted the probability of A or D, the union of the events. Well, now we're back to our two Venn diagrams. This is the probability of A plus the probability of D, delta, minus the intersection, probability of A intersection D, A. So, if the question had asked for probability of A union D, then we take probability of A, that's 0.50, plus probability of D, that's 0.10, minus the intersection, we just found that, by multiplying them together, 0.05. So the answer is 0.55. The book did not ask for this, probability of A union D. This is bonus, extra exciting bonus question for you right here. So that's how you do question 41. Because they're independent, you multiply them together and get 0.05. I'm going to pause it and set up question 48, which is a little bit harder. This is question 48, and it says we're sampling 2 cards at random without replacement. So we take one card, we look at it, then we draw another card. That's typically how you draw 2 cards. And we want H1 is the hearts on a first draw, and H2 is hearts on the second draw. And we want the probability of getting 2 hearts. So they call this the probability of H1 and H2. That's the probability of getting a heart on the first draw and a heart on the second draw. You can see that if you draw 2 hearts, that means you got a heart on the first draw and a heart on the second draw. So these 2 sentences are the same. So now we use our conditional probability. So this is equal to the probability that we get a heart on the second draw, given that we got a heart on the first draw, times the probability that you got a heart on the first draw. Sorry about the barking, that was my dog Leo. Leo's very excited about probability. So, probability of hearts on the first draw and hearts on the second draw is the probability that you got a heart on the second draw, given that you got a heart on the first draw, times the probability that you got a heart on the first draw. This is exactly our conditional probability formula. So it looks weird in this context, but it's exactly the same formula we were using before. So now, what's the probability that we get a heart on the first draw? Heart on the first draw. Well, there's 13 hearts and a total of 52 cards. Whew, that one was easy. What's the probability that we get a heart on the second draw, given that we got a heart on the first draw? So this one, you just have to think about the deck of cards for a minute and think, well, if I got a heart on the first draw, then there's only 51 cards left. And one of them, I took out 1 heart there, so that means there's 12 hearts left. So there's only 12 left because one of them went on the first draw. So the probability that the second draw is a heart is now 12 out of 51. So this is equal to 13. Oops, I should write them in order here. That's 12 out of 51 times 13 out of 52. Because again, this is probability of heart on the first draw, there were 13 out of 52. Probability of heart on a second draw, there's 12 out of 51 left. All of this equals, you could think of it as 156 divided by what? 2, 6, 5, 2. Come on, 5. Equals 0.0588. And your book just lists this number, 0.0588, but I think this one, it's helpful to go over the derivation of this. So the probability that you get 2 hearts, 0.0588, or about a 0.6% chance that, or 6% chance that you will get 2 hearts if you just draw 2 cards from a deck of cards.